Hello everyone, welcome you all to post-contest discussion of Codechef Starters contest. So let's move on to the discussion. We will be discussing the first 6 problems. So our order would be that I would be discussing the second problem first, in which the first one will be automatically included because it is basically the extension of the first one. Then I will be discussing the third problem. After third, I will be discussing the sixth problem because third and sixth are somewhat linked. And then I will be discussing fourth and then the fifth. So I hope all of you understand how we are going to discuss the problems. Okay. So let's move on. Let's start discussing. So this is the first problem that we are going to discuss. The name of the problem is GCD to 1 easy version, but we are going to discuss the hard version in which the easy will be automatically included. Okay. So let's move on to discussing. So this is the hard version of the problem. The only difference between this and the easy version is in this version, you have to minimize the sum of the matrix as well. We will compare them. Okay. So you need to construct a matrix A of size n cross m such that the GCD of every row and column is 1 and sum of elements of matrix is minimized. And every element of the matrix should lie between 2 and 10 power 9. And if there are multiple possible answers, you can print any. So n denotes the number of rows, m denotes the number of columns, and you need to print a matrix of size n cross m. So let's understand what actually the question is. See, so you are given two values. First of all, the number of rows. Second, the number of columns. Okay. Now you have to construct a matrix of size n cross m such that every row has the GCD equals to 1. Do you all understand what do we mean by GCDs? Do you all understand GCDs? Great. So the question is that every row, all are co-primes. Yes, you can, all are co-primes. So basically you can say the GCD of the entire row is equal to 1. GCD of entire column is equal to 1. Not all are co-prime. That is not what we mean, Himanshu. But the question is that the entire GCD of the column should be 1. Not like if we have element x over here and x1 over here. So x and x1 should have GCD 1. This is not required. You require that when you take the GCD of the entire column, that should result into 1. Okay. So if you take GCD of this entire column, it should be 1. If you take GCD of this entire column, this should be 1. If you take GCD of this entire column, it should be 1, and so on for all the columns. And the same holds for row as well. That is GCD for this particular row is 1, GCD for this particular row is 1, GCD for this particular row is 1, and so on. Okay. Now, if let's suppose I would have told you that I want, now the extra condition over here is that you have to minimize the sum. Okay. So you want to minimize the sum. So how we can minimize the sum? If I would have told you that I want to minimize the sum and I want GCD of all the elements to be GCD of all the elements in all rows to be equals to 1 and GCD of all elements in the column to be equal to 1. What is the first thing you all would have preferred? You all would have preferred that, okay, give all the values 1, isn't it? You would have told that give all the values 1 and then I will get GCD of all the rows as ones, GCD of all the columns as ones. And this is also the minimum sum possible. Do you all agree with me? But over here, you have been given that Aij, that is every value in the matrix is greater than equals to 2. Okay? This is one thing that is given to you. So you can't put any value equals to 1. This, if you do this, it will go completely wrong. Right? So what we should do? The second thing that came, this was the first thing that came to my mind, but then I checked that, okay, the condition is greater than equals to 2, so we can't do this. Then what we can do? We are given Aij to be greater than equals to 2, and I know that I can't fill all the values with 2, because if I fill all the values with 2, in that case, the GCD of the row or the column will come out to be 1, right? I can't fill all the rows or columns as 2. So what we can do, if we are not filling it with 2, we will fill with some other number greater than 2. So then I thought that, okay, if I fill some values with 2 and if I fill some values with 3, such that every row has at least 1, 2, and 1, 3. That is, at least a number of ones in the row is, at least a number of twos in the row is at least 1. And similarly holds for 3 as well. Similarly, for every column, you have at least 1, 2 and at least 1, 3. In that case, can I say that the GCD of every row and every column will come out to be 1? Can I say that? That if every row have at least 1, 2, and 1, 3, and every column have at least 1, 2, and 1, 3, the GCD will come out to be 1. And why I am choosing 2 and 3? Because I want to minimize the sum. And I know that every value should be greater than equals to 2, and that's the reason I have chosen 2 and 3. Is everything clear till now? Is everything clear till now? Yes. So now the only thing left is that how will I fill this? So that every row has at least 1, 2, and 1, 3, and every column has at least 1, 2, and 1, 3. Now tell me, while you are filling 2s and 3, what will be your priority? Will you have the priority to keep more number of 2s, or will you have priority to keep more number of 3s? What will be your priority? Say more number of 2s, right? Because you want to minimize the sum. Okay. So now let's take an example where the value of n and m are equal. Let's suppose n is equal to 3, m is equal to 3. So this will be your greed. This will be your greed. Can I say that if I fill the diagonal elements as 3, if I fill the diagonal elements as 3, then I will have every row and every column having the value 3. Do you all agree with me till now? Yes. Now, this was the solution that actually I wrote, and I submitted this solution. But then I saw that, okay, it's not given that the value of n and m are same. So, okay, sorry, this was when we had n equals to 3 and m equals to 3. Okay, we are filling all the diagonal elements with 3. And why we are filling diagonal elements as 3? Because it's given, because this requires the minimum number of 3s, so that every row and every column has at least 1, 3 and 1, 2. Is everyone on the same page till now? Yeah, it's not given n equals to m, but if let's suppose n was equal to m, okay. Now, what if n is not equal to m? Let's suppose I increase the value of m, I increase the value of m to 5. This means I have 5 columns, right? I have something like this. Now what I can do? I know that every row now has at least 1, 3. So every row has at least 1, 3. So I don't need to satisfy the condition for row, but I need to satisfy the condition of these 2 columns as well. So can I say that if I now fill these any two rows in this 2 particular columns as 3 and rest of the values as 2, then I will have every row and every column that is having at least 1, 3 and 1, 2. Do you all agree? So this is what I am going to do. This is how actually I am going to solve the question, that if m, first of all, I am going to fill all diagonal elements as 3 and all the remaining values as 2. Then if the value of m is greater than n, in that case, I am going to fill the first row. I have decided first row, but you can decide any of the rows. Okay. So I am going to fill the first row of the remaining columns with 3. Else what I'm going to do is, if the value of n is greater than m, like let's suppose this was the grid. In that case, first of all, I'm going to fill diagonal elements with 3. And then for the remaining rows, I'm going to fill the first columns with 3. So this is what my intended solution would be. Do you all get the idea? Like how we intuitively went from one point to other? If m minus n is equal to 1. So, Rahul, do you have doubt in this? If m minus n is equal to 1? So you will have m equals to 4, right? So you will fill only one column with 3 over here. Like this point will not be there. That's the only thing. Understood? Great. Great. So let me show you all the solution. This is the solution that I So I constructed a matrix of n cross m. Then I went over all the rows and columns. If I is equal to j, this implies this is a diagonal element. So in that case, I am filling that value with 3. Otherwise, I am filling the value with 2. Now, if n is lesser than m, this means that I have more number of columns. So what I am going to do is I am going to go over remaining columns because I have filled all the diagonal elements. This means that I have filled all the columns till n minus 1. So I will simply start with n, j lesser than m, j plus plus. I will just fill their first row with this particular column as 3. And if m is lesser than n, that is I have more number of rows. This means already till row number m minus 1, I have satisfied the condition. So from row equals to m, till the remaining rows, I will fill their first column with 3. And once I have filled the matrix, I will simply print it. So this is what my solution is. Do you all get the solution? Yes? Great. So the easy version is actually exactly the same. So in easy version, the question was that you have to construct such a matrix such that every row and every column has GCD equals to 1, but you don't need to minimize the sum. Okay. You don't need to minimize the sum. So if you are minimizing the sum, that is the extra thing that you are doing. So you all can relate that the solution of hard version will definitely work in easy version as well. Isn't it? And let's suppose you don't want to solve hard version, you only want to solve easy version. So what you can do is you can fill all the values in the matrix with a prime number. In that case, you will not minimize the sum, but you will have the GCD of every row and every column as equal to 1. So do you all get the idea? Yes? Great. So let me jump on to the third question. So this was the third question. The question name was replace with first. So you are given two strings s and t of lengths n and m respectively. You can perform the following operation on any of these strings. Replace a substring with its first character. That is, let's suppose you have a string A, B, C, A, B, C, and you chose a substring CAP. Do you all understand what do we mean by substring? Do you all understand what do we mean by substring? Contiguous characters in a string, right? From an index, something similar to subarrays. Okay. So you chose a substring, and what you can do is you can replace this. You can replace this entire substring with its first character. So the first character of this entire substring is C. So you can replace this entire substring with first character, and rest of the characters will come as it is. Now the question is that since you're given two strings S and T of length N and M, the question is that what is the minimum number of operations to make both the strings equal? And if this is not possible, you have to print -1. Okay. So you have to tell the minimum number of operations so that you can make both the strings equal. And if it is not possible to make both the strings equal, in that case, you have to print -1. So like, for example, if I take these two strings, accepted and accepted. Let's suppose I take these two strings, A, C, C, E, P, T, E, D, and A, C, C, A, P, T, E, D. Okay. So what you can do is, you can like choose this substring in this. You can choose this substring. And what you can do is, you can remove, you can choose this substring and replace the string by A, C, C, P, T, E, D. And over here, you can choose this substring and you can replace it with its first character. It will come down to A, C, C, P, T, E, D. In this case, you require two operations. And so in two operations, you were able to convert this string to one string to other. Is the answer 2 for this? Yeah, answer is 2. And if they are like equal from before only, so you know the answer will be 0. And let's suppose if you consider this string AABC and AAB, AABC and AAB. In this case, you can choose this substring, replace it with its first character, and you will get this particular string as AAB. This particular string is already AAB. So in one operation, you were able to convert or make this particular strings S and T equal. Do you all get the question? What actually the question is? Yes. Anyone having doubt in the question? No, right? Okay. So looking at this question at first seems a bit difficult. Like when I saw this question first, I was like not able to get to the idea very quickly. But then I started figuring out some things. Let's see what I saw. Like let's suppose I have two strings S and T. Okay. The first string is AABC and the second string is CABC. Say me, can I make this S equal to T anytime? No. Why? Because whenever we are choosing a substring, we are replacing the entire substring with its first character, right? Now, if the first character of these two strings are only not equal, in that case, can I choose any two substrings? Can I choose any two substrings, any substring over here, such that at the first character of this particular string S, I get C? Because if I am choosing any substring, that substring will definitely start with the first one if I am choosing the first character. And then I will replace it with the first character only. So the first characters of S and T will not become equal. So in that case, I will simply print -1. Do you all understand this? Yes? Great. Once I was able to figure out this, once I was able to figure out this, now the next thing that I figured out is that, okay, I have the first characters equal. Let's suppose the first character in string S is also equal to A, and the first character in string T is also equal to A. Then I thought that whatever character string is present over here, let's suppose x1, and whatever string is present over here, let's suppose x2. Tell me, do you all agree that if I choose this particular string in S, and if I choose this particular string in T, so this will result me into A, this will result me into A. So just in two operations, I would be able to make S equal to T. Do you all agree with me in this? Yes? So tell me, if from originally S was equal to T, the answer would be 0. If if S is equal to T, please repeat here. What I told is I already know that the first character in string S and the first character in string T are equal. I know these two things, right? These two things are known to me. So if I choose this particular substring, like the entire string as the substring, entire string S as the substring, and when I apply operation on it, I will just be left out with the first character of this substring that is equal to A. Similarly for T, if I do the same operation, I choose the entire string T as the substring and I apply the operation, I will be left out with the first character of T that is equal to A. Now, since I know already that the first character of S and T are equal, so in just two operations, I would be able to make S equal to T. Yeah, great. So if S is equal to T original, like before doing any operation, so I will simply print 0. I don't need to do any operation. Otherwise, I know that if it is possible to convert S equal to T, I will require less than equals to 2 operations. Do you all agree? Anyone having doubt till now that why I am saying that I will require less than equals to 2 operations? No? Great. So now I need to figure out, I know when I will require 0 operation, when originally S is equal to T. I know when I will require 2 operations. Like for doing 2 operations, I know I can easily do it in 2 operations. Now the only thing that I need to figure out is that can I do it in 1 operation? This is the only thing that I need to figure out. Do you all agree with me in this? That this is the only thing that I need to figure out. Because if I can do in 1 operation, if I can't do it in 0 operation, if I can do it in 1 operation, the answer will be 1. If I can't do in 1 operation, the answer will be 2. Do you all get this till now? Yes? Great. So how to figure out whether we can do it in 1 operation or not? So this is actually, let me tell you why. Let's suppose this is a string S. So do you all agree that if I am doing it only in 1 operation, so I will modify only one of the strings, not both, right? I will modify only one of the strings. Do you all agree? Yes. And if I am modifying only one of the strings, can anyone say me which string I will modify? Can anyone say me which string I will modify? The longer one, right? The longer one. Do you all agree with me? The one which has a larger size, that is the string that will be modified. See, Harish, I am modifying, when I modify a string, do you agree that the length of the string decreases? Yes. So now just apply some brains. If I am having two strings, if I am modifying a string, the length of the string is going to decrease. And I can modify only one string, and that too only one time, because I am doing only one operation. So do you agree that the one that is having the longer length will be modified? If someone has length 2, someone has length 4, and I want to make both these strings equal. So if I am making both these strings equal, their length will be equal. So if I modify this string, its length will decrease more. So why will I modify this string? If I need to modify, I will modify this string so that its length becomes equals to 2 and becomes exactly equal. Do you get this now? Yes, great. So I will modify the longer one. Okay. So let's suppose T is the string that is longer one and S is a string that is shorter. Okay. And S is something like, or let's suppose S is the longer one. You can take anyone longer, anyone shorter. Let me take S as the longer one. Okay. So A, B, C, A, B, B. And let's suppose T is A, B, B, B. Okay. This is my T. Now, since I am modifying this string only once, do you all agree that I will remove some substring from here? And then when I concatenate the left part and the right part, the answer will be exactly equal to this T. Do you all agree with me in this? Since I am doing only one operation. So the thing is that I am going to remove some substring from S and if after removing such substring, I get the remaining string exactly equal to the string T that I have, can I say, that in one operation, I will be able to make S equal to T? Do you all get this idea? So the only thing that is left is, what I will do is, I will initialize my I over here, okay? While this S of I is equal to T of I will keep on incrementing my I. My I will come down to over here, okay? The prefix is matched. Now I will initialize one index J1 over here and one index J2 over here. Point up till which I get the like prefixes equal J1, J2, I will just move on. I will just keep on moving. Once I get that I have got my entire string formed, I will simply stop and I will say that, okay, I can form this string. What I told is, first of all, I will initialize my I to 0. Why S of I is equal to T of I will keep on incrementing my I to see how much longest prefix we can take. So do you all agree that in this particular example, my I will come down to 2? Because at I equals to 0 and I equals to 1, we will increment our I, right? So our I will come down to 2. Now what we will do is, we will initialize our J1 with 0, 1, 2, 3, 4, 5, 5. This is basically index 5. And I will initialize my J2 with index 3. Now while S of J1 is equal to T of J2, I will keep on decrementing my J1 and J2. But till which point I will decrement my J2? I will decrement my J2 till the value of J2 is greater than equals to I. Once my J2 becomes lesser than I, do you all agree that I will be able to form the entire string? Because I have got a suffix, I have got a prefix, combining which I was able to make this string T. So I can easily remove the substring in between and I can construct my answer. Isn't it? So this is how actually I am going to solve this question. I am going to see the longest prefix that I can take from left. I am going to take the longest suffix that I can take from right. If on combining them, I was able to form the string, then all right. If not, then the number of operations is 2. I can't do it in one operation. Do you all get this solution? Should I show you the code? Yes, great. So let's jump on to the code. So this was the code to this solution. I took inputs of n and m and then string s and t. If s of 0 is not equal to t of 0, so in that case, I know I can't make s equal to t, so I am simply printing -1. Else, if s is initially only equal to t, I am printing 0. Okay. Now, if n is greater than m, so what I am doing is I am making t the string with the larger length. Okay. So if n is greater than m, I am swapping this n and m, and I am swapping this s and t as well. So t is the one that is having the longer length, n is the one, s is the one which is having the shorter length. Okay. Because so that I don't have to write those things two times, like if n is greater than m, else writing these condition two times, we can minimize that by just making string s the shorter one and t the longer one. This is a very common practice. Okay. Now, if I is equal to n, wait a minute. Yeah. Now I initialize my I to 0. While I is lesser than n and s of I is equal to t of I, I am simply keep on incrementing my I. Okay. If at the end I get I is equal to n, do you all agree that I can print 1? If I is equal to n, n is the shorter length. So if I is equal to n, I can directly print 1 that, okay, the prefix only matches. Okay. Otherwise, what I did is I initialized j1 to m minus 1 and j2 to n minus 1. While j2 is greater than equal to I, as we already discussed, and t of j1 is equal to s of j2, I am keep on decrementing my j2 and keep on decrementing my j2. If after coming out of this while loop, my j2 is lesser than I, this means that I can do the operations in, I can simply make this strings s and t equal in one operation, so I am printing 1. Otherwise, I am printing 2. This is actually the code to this question. Do you all get this? Anyone having doubt in this question? The code or anything else? Uh, this actually passed for me. So Anshul, you can once check your answer whether you are doing all the things or not. So this actually worked for me. I got the correct answer. And it should work as well. Like we have proved this, right? Anyone having doubt in this question? No? Great. So Harish has a doubt in previous question I related to the GCD easy part. What if I fill all the matrix and with 2 in all? No, if you are filling 2 with all, how will the GCD of every row and every column will come down to 1? In that case, the GCD of every row and every column will come down to 2, right, Harish? If that was the case, in the hard version only, we would have filled all the values with 2. Because the main aim was to minimize the sum. If the GCD condition was not there, in that case, we would have filled the entire matrix with 2 to minimize the sum. Okay, great. Any other one having doubt in like the 3 questions we have discussed? No? Great. So let's jump on to the 6th problem actually. Yes, Akshay, we are doing that. So actually what you have written for that, we can say that if the largest common suffix plus largest common prefix is greater than equal to the smallest string, you can add over there greater than equals. Okay. So let's jump on to the 6th solution first, then we can discuss the, because the 6th question and this particular question share some similarity. Greater than equals to, because what I told is like if you have the shorter string, let's suppose as A, B, B, and the largest string as A, B, then A, B, B. In this case, you can see the longest common prefix is 3, the longest common suffix is 3, and longest common prefix is also equals to 3, right? So, you know, you can take some part of suffix and some part of prefix and combine them, right? And you can remove the between part. That's why. But while writing the code, I have actually taken that in. I have taken that before only because I was breaking when J was lesser than I, right? So I am not taking that condition. I am making it exactly. Uh, so let's discuss this question. This was the sixth problem. So in this question, you are given two strings S and T of length. This question remains the same. You can also see if string is a, what do you mean by that, Gurkita? Wait, I am allowing you to unmute. Kindly let me know when.
मैं ये कह रहा था कि लाइक अगर वो सब स्ट्रिंग है लॉन्गर वन की तो भी तो हो ही सकता है।
तो प्रेफिक्स में ही आ जाएगा ना।
या बट हमारे पास इनबिल्ट फंक्शन में शायद सब स्ट्रिंग चेक करने के लिए।
That takes the complexity of big O of n actually, like. So that's the reason, like if we, let's suppose you have a substring. In that case, do you agree that I have to do two operations now? Like the first character needs to be included.
ओके
For two characters, we have already worked out the case. We were discussing only when, if let's suppose we can do the things in one operation. For two operations, we have already worked out the case.
ओके
Yes. So we were working, we were seeing that can we do it in one operation or not. And if we are able to do in one operation, this means that from the longer string, I will remove some substring from between.
ओके थैंक यू।
Yes. Anyone else having doubt in this? Okay. So this was the sixth problem. So if anyone is not familiar with DP, I would just recommend just skip this. You can skip this solution. It is actually based on DP. So give me 10 to 15 minutes. I will discuss this problem and then the remaining two solutions. So you can wait a bit. Okay? So the question is that you're given two strings S and T of length N and M. You can perform the following operation on the string S. That is, you can replace the substring with its first character. The question is exactly the same. The only difference between this version and the version that was given before is in this particular question, you can only change string S. See, you can perform the following operation on the string S. You can't perform the operation on the string T. So do you all understand what the difference between this question and the previous one was? Yes. So how we can do this one? For this, you can see the constraints is also a bit low. Like the constraints is n and m is of the order of 2 into 10 power 3. So looking at this, we can say that n square will definitely work, right? So for that, what we can do is we can use d. See, if I am given you a string s and I have given you a string t. So do you all agree that if let's suppose string s is a b, a c a, string t is let's suppose a c a, okay, and let me include one c word. So tell me what is the minimum number of operations that you need? Tell me. By looking at this, what is the minimum number of operations you need? Two. One. Anyone else? One. You can modify only string S. Okay, string T can't be modified. One, right? Yeah, you need one operation. See, if you select this substring and just take its first character, you will be left out with ACA. So do you all agree that I will require only one operation? Do everyone agree? Yes. So now the thing is that if you apply the greedy idea over here, you will not get one. Why? Greedy idea says that if you can take, then take. I can take A, great. Move on to the next index. I can take C, yes. Can I take B? No, I can't take B. So in that case, I have to apply one operation. Can I take A? The answer is yes, I can take. So let's take. Can I take C now? No, I can't take C. Can I take A? I can't take A. Now these two characters can be removed only in one operation. So the greedy idea tells me that I can work out, like I can make this string S equal to T in 2 in T, S equal to T in two operations, but you all have seen that the answer is 1. isn't it? Greedy, if you apply the greedy idea over here, you will get the answer as 2, if you can see over here. Do you all have doubt in this, that why greedy will not work? Do you all agree that why greedy will not work? Yes? So now, how we can do then? Greedy is not working. So when greedy does not work, then many a times DP works, right? So what you can do? You have two indices, I and J. See, if let's suppose I want the ith character in S. If you don't know DP, I would recommend please skip this one. Like, or you can be with me. First of all, I will write the recursive solution, and for DP I will simply memorize it in one step. So you can understand the recursive solution and you can skip the DP one and follow. Okay. Try to understand the recursive solution. Okay. So DP is basically for reducing the time complexity. Yeah. Let's suppose I tell you that I want the I am in the ith character in S, and I am in the let's suppose I tell you that I am in the ith character in S and I am in some jth character in string T. I want to make S and T equal and I can only modify S. Do you all agree that if S of I is not equal to T of J, then I have only one condition. That what I do is I just move on to next index I. I simply move my index I to I plus 1. I don't have any other options. Do you all agree with this? Because every character of T should be matched to some character of S. So if ith character of S is not equal to jth character of T, I can say that, okay, to get this jth character in T, I have to move on to the next index in S. Do you all agree? Yes. So if I just construct a helper function, this is a recursive function, I comma j. This basically tells me that if I am at ith character in S and jth character in T, then tell me the minimum number of operations I need. Okay. So can anyone tell me the base case for this recursion? Can anyone tell me the base case for this recursion? Which one equal to 0? Like I am going in increasing order. Okay. So let's suppose this S was of length n and T was of length m. So can I say that if my J becomes equals to m, this means I don't want any more characters from S. So do you all agree that if I is equal to n in that case, then I can simply return 0. Else, I can return 1. Do you all agree with me in this? And if j is not equal to m, but I has become equal to n, can I say in this case, I can't make s equal to t. In that case, I return, since I am taking minimum at all steps, I am returning some maximum value. Let's suppose I return 1 in 5, some maximum value. Do you all agree with me in this two base cases? Anyone having doubt in this? No? Repeat. What I told is that if the string T is completely completed, how will I get that? If J it becomes equal to M, that is I don't have any more characters in T to take. In that case, if string S is completed, then I can return 0. I don't have to remove any more characters from S. But if S has not become equal to N, I has not become equal to N. Let's suppose this was S, A, B, C, D, E, and this was your T, A, B, C. So you were standing over here, but your J has already completed. This means that the remaining characters needs to be deleted, the remaining characters, and they can be done in one step. So if I is equal to n, I am returning 0, else I am returning 1. So this was when j is equal to m. And if let's suppose j is not equal to m, but I has become equal to m, this means I have some more characters in string t to complete, but my string s is already completed. So do you all agree that in that case from s, I will not be able to form t? So in that case, I am simply returning 1e5. So that is the maximum value. Okay, great. Now, once you understand this, now there are two cases. If s of I is equal to t of j, this is one of the cases. Else, there is a second case. If s of I is equal to t of j, do you all agree that you have two options? Either you take that particular character or you don't take that particular character. Take, not take. Do you all agree? I have two options that I either take or not take. If I am taking, do you all agree that my helper function will be passed to I plus 1, j plus 1? And if I am not taking, my helper function will be passed to I plus 1, comma j. Do you all agree with me in this? And if I go to else condition where s of I is not equal to t of j, in this case, I can definitely not take. I can definitely not take. So over here, I have only one option, that is helper of I plus 1 of j. Do you all agree? Why will you not take? Because as we already discussed, the greedy idea will not work, right? That is every time if you can take, if you take that, you will not get the minimum answer. So even if like over here, you can take this two C's, but you will not take. You will not take it, right? You will remove this entire substring. Even if you can take, it may be that if you don't take it, you will get the minimum answer. Yes, great. So do you all get this? Now, if you see, like if I am like, let's suppose A, this is string S, this is A, B, C, A, D, E. Let's suppose I decided that I am not going to take these four characters. Do you all agree that in this case, if I am not taking all four characters, if I am not taking all four characters, I require only one operation. Do you all agree with me in this? If I am not taking all four characters, I don't require four operations for them. I require only one operation. I require only one operation and I will be able to remove all of these four characters. Yes. So along with this I and j, I will keep an extra variable that is flag. And what will this flag tell me? Flag tell me that have I taken previous character or not? Have I taken the previous character or I have not taken it? Let's suppose I have taken the previous character. So do you all agree that if I am not taking the current character, in that case, my number of operations will increase by 1? If I have taken the previous character, but I am not taking the current character, do you all agree that my number of operations is going to increase by 1? Yes. And if I have not taken the previous character and I am not taking the current character as well, do you all agree in that case my number of operations are not going to increase? Yes. So this is the simple logic that I will apply to this question. And why taking flag works, because see, you have I, J, and flag. So the states of DP will be your I will maximum go till n, J will maximum go till m, and this flag is 2. So your time complexity will be n cross m cross 2, and this will definitely pass the given constraints. And that is why taking this flag helps us in solving this question. So let me jump onto the code. So let's understand this solution. So what we have done is we have taken this string n and m as input, then string s and t as input. If s of 0 is not equal to t of 0, in that case, we are printing -1, exactly the same. Do you all agree with me in this? Anyone having doubt in this? That if s of 0 is not equal to t of 0, the answer will be -1. Anyone having doubt in this? Yes, great. Then what I did is I constructed a DP of size n cross m cross 2. So basically 3D DP is constructed. Then I made a helper function. In this helper function, I have three variables, I, j, and flag. So do you all agree that the first character will always be taken, right? The first character will always be taken. That is why I have passed my I as 1, j as 1. And since I have taken the previous character, I have passed my flag as 1. Do you all get this? Now, what I did is I constructed a lambda function. So if any one of you is not familiar with lambda function, so it is just behaving like a normal function. Just think of it like a normal function. Okay. Like just for syntax purposes or simplifying purpose, I used a lambda function, but it behaves exactly the same as the simple function. So in the function, you have three things: the current index of string s, the current index of string t, and the value of flag. If j is equal to m, that is, you have reached the end of string t. In that case, if I is equal to n, you are returning 0. Otherwise, if I is not equal to n and you have taken the previous character, in that case, you have to return 1. If you have not taken the previous character, you have to return 0. So just for simplifying purpose, I wrote return flag equals 1. So if flag is equal to 1, you have to return 1. Otherwise, you have to return 0. Otherwise, if j has not become equal to m and I has become equal to n, in that case, I am returning some big value, that is 1 if. Then just forget this DP step. If s of I is not equal to t of j, I am passing a recursive function in which I changes to I plus 1. And since I am not taking the current character, my value of flag changes to 0. And j remains as it is. What will be my answer? My answer will be answer whatever I got from here plus flag equals 1. That is, if the previous character was taken, and since I have not taken the current character, that means my answer is going to increase by 1. So answer plus flag equals 1. And I am returning from it. So this is basically the else condition. That is, I have an option that I can either take or not take. So the first answer one is one. This is the one when I have opted for not taking the current character. In that case, the recursive function simply passes I plus 1, j, and the flag changes to 0 since I have not taken the current character, plus whatever answer I get from here, plus since I am not taking the current character, so my answer will increase by 1 if I have taken the previous character. So I am just adding flag equals 1. And if I am, let's suppose, taking this current character, in that case I am simply passing I plus 1, j plus 1, and since I am taking the current character, I am changing my flag to 1. So I will simply return minimum of both these cases. For DP, this is a simple memoization what I have done. If DP of I of j of flag is not equals to 1, I am simply returning this. Otherwise, I am just doing this operation, and every time when I am returning the answer, I am also storing it in that particular state. So this is a normal memoization step that I have done. So do you all get the solution? Anyone having doubt in any of the point? The ones who don't know the DP, did you all get the recursive step, what we have done? So it was a simple take not take recursion type, right? Cool. So let's discuss the fourth problem now. Give me a minute. I will have some more time. Yes. So the name of the question is prefix, suffix, min, max. Let's go through the statement. There is an array A with integer elements of size n. We create another array B where Bi is nothing but summation of j equals to 1 to I aj minus maximum from A1 to AI. So you are given this array B and you are asked to find any valid array A. And it is given that for a given B, the solution always exists. Okay. So let me show you all what actually the question says. So the question is 0, -1, -2, 1. So you are given an array B. 0, -1, -2, 1. Okay. How is this B constructed? So to get how this B is constructed, let me take a valid A for this. The valid A for this is 3 -1 -1 3. 3 -1 -1 3. So let's see how from this particular A we are going to get this B. Bi is basically equal to summation of j is equal to 0 to I aj plus maximum of, this is one term, okay, plus, sorry, minus maximum of a0, a1 up till ai. This is how actually you are constructing bi. Okay. So if I tell me what will be b1, looking at this a, just forget this b. Looking at this a, tell me what will be b1. B1 will be basically the sum of first one element minus the maximum till first one element. Do you all agree that B1 will be equal to 0? Yes. What will be B2? What will be B2? Sum of first two elements in A, that is equal to 2, minus the maximum in the first two elements, that is equal to 3. So do you all agree that B2 will be -1? Yes. What will be B3? Sum of first three elements in A, that is basically equal to 1, minus the maximum in the first three elements, that is 3. So do you all agree that B2 will be 2 -2? And then talking of B3, so B3 will be the sum of all the elements, that is 6 -1 4, minus the maximum in all these. So maximum is 3. So it comes down to 1. So the B3 will be 1. So from this particular A, do you all get this B? Is this B obtained? So now the question is that you are given this B. B is given. You want a valid A. And it is given that for the given B, you will always have some valid A. Okay. So do you all get the question, that what actually the question wants to say? Anyone having doubt in the question? No? Great. So how we can solve this? So to solve this question, it was actually pretty easy. See how. If I tell you that assume that always the first element of A is the maximum element of the first element of A is the maximum element of the entire array A. If you assume this, the question is solvable in just 1 to 2 minutes. Let's see how. Let me tell you that this is A1, A2, A3, A4. This is a valid A this is the valid A you need to find. And let's suppose the B that is given to you is B1, B2, B3, B4. This is given to you. Okay. So now all of you know that the first element, that is the first, so this is your answer. You want some A. So all of you know that this first element is the maximum of all the elements. let's suppose this element is x. Okay. Let's suppose this element is x. Can I say, that this particular element, that is B2, will be equal to B1 plus B2 minus x? Do you all agree with me in this? Just a minute. Yes. Yes, sorry for that. B2 will be equal to A1 plus A2 minus x. Do you all agree with me in this? Yes. Now I know that the first element is a maximum element. Let me break this down a bit. Can I write this as A1 minus x plus A2? Yes. So can I write this is nothing but what is B1? So can I write A2 is nothing but B2 minus B1? Similarly, if I write B3, B3 is A1 plus A2 plus A3 minus x. If I simply break this down a bit, it is A1 plus A2 minus x plus A3. This is nothing but B2, B2 plus A3. So can I say that A3 is nothing but B3 minus B2? Can I say this? Via this, can I find all the A's? And now you will get the intuition why I fixed the first element as the maximum element. Why minus one, Saksham? Why minus one? Okay, bi minus one. Okay, okay, okay. Sorry. Bi minus one. Okay, yes. Yes, this is actually what the solution is. And now you all will get that why I actually fixed this first number as the maximum element. Because fixing first element as a maximum element, I was able to break this down. When I broke this down into A1 minus x plus A2, I was able to write A1 minus x as B1 because I know this x actually remains the same for every sub-array. This x remains the same because this x is present at the front of the array, isn't it? So do you all get the logic? And now what is the first element of the array? A1. Whatever element you have got, just take maximum of all those and just write the first element. Whatever element you have got, A2, A3, up till AN, you know the first element should be the maximum of all. So simply take maximum of all of them and place it at A1 and you will get your required valid A. This is actually the solution for this question. Let me jump onto the code. So uh, while implementing, I actually didn't write it so cleanly as was my explanation, but see what I have done. I have initialized my sum to 0. So you all can write it down in this way as well, like AI is nothing but BI minus 1. That also works. But what I have done is I have just taken my temp as BI minus sum. So what I am doing is I am just maintaining all the sum of all the elements in A. Okay. So I'm writing my temp as bi minus sum. In my t, I simply pushed back temp, and I am just keep on incrementing my sum. If n is equal to 1, I am just printing 0, some random number. Otherwise, I am printing the maximum element of all these t, and then I am printing all the elements of t. This is what I am doing. Do you all get the solution? If anyone is having doubt in this, I can explain this as well. I can explain. Anyone having doubt in this, what I have done over here? I can explain this as well. Look, let me explain this. What I have done is, I know that A1 plus A2 plus A3 plus A4 plus dot dot up to AI minus the maximum element of all these minus, let's suppose, X is given to you as BI. Okay. So if you want AI, yeah, if you want AI, so what you can do over here, you know that A1 and X will get cancelled. A1 and X will get cancelled. So you can write AI as equal to BI minus A2 plus A3 up till AI minus 1. And this is something what I am storing in my sum variable. So I can write AI as equal to BI minus this. So I've initialized my sum to 0. And as I am getting all the values, as I am getting the values, I am just adding them in my sum as well. So I'm just subtracting b of I with sum and pushed back in my temp. So this temp, t, and t contains all the variables, all the answers for all the indexes. Just for the first index, the answer is not. So for the first index, the answer will be the maximum element of all the values that I have got. And if n is 1, I am simply printing 0 and return. Otherwise, I am printing the maximum value of all the elements, and then I am printing the rest over n minus 1 values. Do you all get the code? Anyone having doubt in the code? Yes? Great. So we are left out with this question right here. So this was actually a better one in comparison to sixth one that we discussed. And it needed some hard work to actually out how we can actually solve this question. Once you figure it out, then the question is somewhat easy. But yes, let's see how we can do this. The name of the question is array concatenation. Count the number of Boolean arrays with A zeros and B ones such that the following condition holds. Let A be the Boolean array and AI be the subarray A1 to AI. So AI is basically a prefix array till index I. What you are doing is you are concatenating A1, A2 up till A of A plus B, and let's call this array as B. The number of ones on odd and even indices in the array B are equal. So you need to print, you have to constructed this array. And once you construct this array, the number of ones on odd indexes and even indexes should be equal. Okay. So how many arrays A you can construct? Just print modulo 1e9 plus 7. And it's given that A plus B is always equal to even. If I just simply take down one example, if I let's suppose take this example of 2 and 2. So it's given to you that the value of A is 2 and the value of B is 2. This means that you want to have two zeros and two ones. So how many arrays you can construct? So do you all agree that if I have two zeros and two ones, the final length of the array will be 4? There will be some A1, there will be some A2, there will be some A3, and there will be some A4, right? How you are constructing array B? First of all, you are taking A1. Then you are taking the subarray from A1 to A2. Then you are taking subarray from A1 to A3. Then you are taking subarray from A1 to A4. Okay. So this is what your actually array B is. The question is that in this array B, the number of ones in the odd indexes, number of ones in the odd indexes should be equal to number of ones in even indexes. This is actually the question. So you have constructed this array A1, A2, A3, A4. After that, you are constructing this array B. And in this array B, the number of ones in the odd indexes should be equal to the number of ones in the even indexes. So the question is that how many arrays A is possible? Do you all get the question? Yes, great. How we can do this? So while doing this, the first thing that I did was exactly the same what I have done right now. I wrote this array B for let's suppose the length as 4. It is given to you that the length is even, right? It's given to you that the length is even. By length even, what do we mean that? A plus B is equal to even. It's given to you. Okay. So what I did was I constructed this array B and wrote down the indexes present in odd positions and wrote down the indexes present in even position. Let me do the same. Let me write down the indexes present in odd position. They will be A1, A2, A2, A1, A3. Okay. And let me write down the indexes present in even position. Like what are the values of A that are getting into this even indexes in this array B? A1, A1, A3, A2, A4. Do you all get this till now what I have done? I have just wrote down the index values present in values of array A, present in odd indexes in B, and present in even indexes in B. Okay. And why I have done that? Because I want the number of ones in odd indexes should be equal to number of ones in even indexes. So for that, basically, I want that A1 plus A2 plus A2 plus A1 plus A3 should be equal to A1 plus A1 plus A3 plus A2 plus A4. This two should be equal. Okay. This is what we require, right? These two should be equal. Number of ones in even indexes and number of ones in odd indexes should be equal. Do you all get this? Yes? Yeah. So if you just look over here, if let's suppose assume this has LHS and this has RHS, so some terms will get cancelled. Let me cancel those terms. This A1 gets cancelled. This A2 gets cancelled. This A1 gets cancelled. This A3 gets cancelled. In top, you have A2 left. In bottom, you have A4 left. So do you all agree that A2 should be equal to A4? Do you all agree with me? Now there will be an interesting thing that will happen. When I took length as equal to 4, I got A2 should be equal to A4. When I will take length as equal to 6, so this is a homework for you all. If you just write this down in the same manner and just cancel the terms, you will get A2 plus A6 to be equal to A4. When you take length as 8, so up till 8, I have taken while I was solving the question. So you will see A2 plus A6 comes out to be equal to A4 plus A8. If you take length as 10, you will get A2 plus A6 plus A10 is equal to A4 plus A8. If you take length as 12, so you will get A2 plus A6 plus A10 is equal to A4 plus A8 plus A12. This means number of ones present in index 2, 6 and 10. Their summation is equal to the number of ones present in index 4, 8 and 12. Are you all able to observe some pattern over here? Are you all able to observe some pattern? Yes? So what is the pattern? In LHS, you are getting 2, 6, 10, starting from 2, all the difference with 4. 2, 6, 10, up till the length permits. 14, 18, something like this. And in RHS, what you're getting? All the multiples of 4. 4, 8, 12, 16, something like this. You're getting all those values, right? This means the number of ones present in these indexes, their summation should be equal to number of ones present in these indexes. Isn't it? So what I can do is I can just simply iterate that, okay, in this particular, in the summation of all these indexes, how many ones I have? 1, 1, 2 ones, 3 ones, 4 ones, 5 ones up till this. Okay, I'm just iterating over that. And let's suppose I have length as 6. Let's suppose, let me take length as 6. Okay. So what I know is summation of A2 plus A4, A6, the number of ones that I have in A2 plus A6 should be equal to the number of ones that I have in A4. So this was the thing that was needed to be implemented. So what I did was, I took that, okay, I assumed, let's suppose A2 plus A6 have 0 number of ones. Then A4 will also have 0 number of ones. Then I assumed, let's suppose A2 plus A6 have only 1 ones. Summation of A2 plus A6 give me only 1 one. So A4 will also have 1 ones. Then I assumed that A2 plus A6 have only 2 ones. So A4 will have 2 ones as well. But can A4 has 2 ones? At max, A4 can have 1, right? So you will just stop over here. You will not go over here. You will only go till here. And you can observe this value is like less than equals to n by 4. Because at max, you can have n by 2 ones in this and n by 2 ones in this. Like at max, you can have in total of n by 2 ones. You can see you have all the multiples of 2, right? 2, 6, 10, 14, 18, 4, 8, 12, 16. So all the multiples of 2 are taken. So at max, their summation, that is this LHS plus RHS, can be equals to n by 2. So at max, you can have in a particular LHS or in a particular RHS, at max, you can have n by 4 ones. Because in LHS, if you have n by 4 ones, in RHS as well, you will have n by 4 ones, and their summation will come out to be n by 2 ones. So I can say that maximum there will be n by 4 ones, and this is how actually I solve this question. Like assuming that LHS have only 0 ones, LHS have only 1 1, LHS have only 2 ones. Now let's suppose I give you this. If I want to solve this question, that these are the indexes 1, 2, 3, 4, 5, 6. And I know that number of ones in A2 plus A4 should be equal to number of ones in A6. And I assumed that A2 plus A4 have 1, 1. Okay, I assumed. How can I solve this question now? Can I say that can every one of you find the leftover positions? How many positions are left over? A2, A4, A6 are not considered. So how many positions are left over? A1 is left out, A3 is left out, A5 is left out. Can I say leftover positions are 3? Yes. And if A2 plus A4 have only 1, 1, so in how many ways can I fill 1, 1 in A2 and A4? Can I fill it in 2C1 ways? I have 2 spaces. In that, I will fill only 1, 1. So can I fill only 2 spaces? I can fill only 1 space. So I will just select 2C1. Multiplied by A4 have only 1, 1 to fill. Sorry, just a correction over here. Yeah. So A4 have only 1, 1 to fill, and the space is also 1. So in how many ways can I do this? Do you all agree that number of ways I can do this is 1C1? Yes. And for the remaining spaces, I have 3 spaces remaining. I will have some ones left. I will have some zeros left. Okay. So can I tell that from the leftover spaces, if I just select some spaces for 1, so can I write it like 3C1s left? If I select some spaces for 1, so in the remaining spaces, 0 will come down automatically, and this will be my answer. It will not be 2 power 3 section, because you have the fixed number of ones and fixed number of zeros. So there will be some ones left, there will be some zeros left. So for all the remaining spaces, you have to see in how many different ways you can fill them with the remaining ones and zeros. So that is what we are doing. Got it? Great. Do anyone of you have doubt in the solution? How actually we implemented it? The only thing over here, the difficult one was to figure out this pattern. Once you are able to figure out this pattern, then the things will become easy. So you can see that the LHS have how many terms? Like you can work this out. LHS have n by 2, all the multiples of 2 minus all the multiples of 4. This many terms. RHS have how many terms? N by 4 terms. All the multiples of 4 are present in RHS. So these are the number of terms present in LHS. These are the number of terms present in RHS. Let's see the solution. Let's see the code. So now this question requires mod operation. And this question requires you to calculate NCR. So what you can do is you can pick up any of the article from Geeks for Geeks or some online, and you can see how you can calculate NCR in using mod operations. Okay. What I have done is I have used this module mint. So this helps me to calculate NCR taking into account this mod operations as well. So for that reason, I have used mint. If you all want to read mint, you can refer to some articles of USACO guide. And else you can just take up some articles where you can calculate NCR. So yeah, in CSS, you have the calculation of NCR modulo 1e9 plus 7. So you can just do that. Okay. So let's see how I have implemented. I have first of all taken the number of zeros and ones as input, initialized my answer to 0. The total number of ones and zeros, the total length of the array that will be formed is a plus b. Now I am only iterating from I equals to 0 to I less than n by 4. I basically tells me that how many ones I have decided that I will keep in a particular LHS. Okay. How many ones I will keep. So you all know that I can keep maximum n by 4 ones, right? I can't keep more than n by 4 ones. Why I'm talking like that? If I keep n by 4 ones in LHS, then I have to keep 1 by 4 ones in RHS as well, n by 4 ones. This will sum out to total number of ones as n by 2. And you know that a total space of LHS and total space of RHS is lesser than equals to n by 2, right? You have all the multiples of 2. That's all. Total, if you have LHS as A2 plus A6, RHS is A4 plus A8. The maximum you will have is 2 plus 2, 4. That is nothing but 8 by 2. That is n by 2. So that's the reason the maximum number of ones that you can keep in a particular segment, that is LHS or RHS, is basically n by 4. So just I iterated over the number of ones in a particular LHS. So from 0, I iterated till n by 4. So first of all, I calculated the number of numbers that I have in left hand side. So it is n by 2 minus n by 4. The number of numbers that I have in right hand side, that is n by 4. The leftover spaces will be n by 2. What are the number of zeros left? So see, in space 1, if let's suppose I told you that I am filling it with I ones. So whatever space is not occupied by ones, they will be occupied by 0. So can I say that the number of zeros that I left is total initial number of zeros minus from space 1, I have filled I ones. So all the remaining spaces were filled with 0. So this many zeros will be subtracted. Similarly, in space 2, I have filled it with I zeros, I ones. So this many zeros will be there. So it will also be subtracted from A. So do you all agree that this many zeros I will be left out with? Similarly, can I say that the number of ones that I will be left out with is the initial one minus 2 into I? I number of ones in space 1, I number of ones in space 2. So these are the number of zeros that I am left out with. These are the number of ones that I am left out with. And if the zeros I am left out with is lesser than 0, so this means that this is not a valid case. So in that case, I am simply continuing. And if the leftover spaces is not equal to number of zeros left plus number of ones left, because the leftover spaces should be exactly equal to the number of zeros that are left to be filled and the number of ones that are left to be filled. So in that case also, I am simply continuing. I don't think that I need to write this condition. Even if you ignore this line, you will not get wrong answer. Okay. Then what will be our answer? Our answer will be from the leftover spaces, NCR with n as left and r as any of the zeros left or ones left. So this multiplied by, from space 1 you select I positions, multiplied by, from space 2 you select I position. And since I am in my answer, I am calculating the total value. So I simply incremented my answer with temp and I am simply printing the answer. So this is actually how I solved the question. I just added all the cases in my answer and I am printing the answer. This is actually the solution to this question. Do you all get this? Yes. Great. Okay. Thanks for joining.